Hello, Sauce here. This is a lesson on using the algebraic process to solve an equation. And the equation that we're going to solve is 0 is equal to 2 times the square root of all 9 minus x and then minus 4. This is an advanced algebra level equation. It's assuming that you have fairly good working knowledge of algebra. But before I jump in and show the thorough process, I'm going to slow down a little bit and be precise in what I mean to solve for, to have a solution, and what we could call the golden rule of algebra. So I am going to find a solution, a value for x that makes this true, by first solving for x. And there's a subtle difference in what we mean by the words or the term solve for and solution. Solve for means to get a variable alone or by itself and positive. It's not solve for if it's by itself and negative on one side. And what we mean is one side of the relation or equation. That's what it means to solve for. So to get a solution, I'm going to focus a process to solve for x. Get it alone and positive on one side. It's not alone. There are numbers and operations being done to it on this side. When I solve for x, what x will be equal to, if it's a value, is a solution. And a solution, to be precise, is a value or values, because we could be trying to find solutions to systems of equations. That's more than one equation at the same time. So a solution could be more than one value. It is a value or values that make a relation true. And what it means for something to be made true, I'll give you an example of when we get to that point in the process. And notice that in the definition of a solution, I've used the word relation, because we can have solutions to inequalities, and inequalities and equations are all relations. This example here is a relation that's also an equation, because we're using an equal sign instead of an inequality sign. So the definition of solution is also useful for inequalities. Now the golden rule of algebra is informal, is what you do to one side you must do to another, or the other. But the golden rule that I'm going to write down for you is enhanced. It's a little more useful because it keeps a couple more things in mind. I put it in quotes because this is informal. To undo an operation, which you will be doing when we go through the process, to undo an operation, do the inverse of what you see to the entirety of both sides. So I have been a little bit slow in being precise about what I mean to solve this equation. But I'm doing that because thinking this way and practicing thinking this way can speed up the process and be more thorough and be more correct and get you unstuck when these problems become more difficult in the future. So this is a very thorough process. Let's use it. I want to get x by itself. I want to solve for x. I can see that I am taking it away from 9. I'm square rooting. I'm multiplying by 2, and I'm subtracting 4. It's about 4 different operations, actions that we are doing to x. One at a time, I'm going to undo those operations. I could do anything I wish. So there are several choices I could make. But often there is one choice that is simplest. And it's a matter of opinion sometimes, but this subtraction of 4 is the first thing that I'm going to take care of. I see subtraction of 4. How do I undo that? I undo it by its inverse addition. I'm going to choose to add 4 to both sides, the entirety of both sides. So I represent my work, the choice that I've made on both sides. And I show what's left after I have done that to both sides. So I have a 0 plus 4 makes 4. And inverse operations cancel each other out. So if I have a subtraction by 4 and an addition by 4, those will cancel each other out, leaving what's left on that side is 2 times the square root of 9 minus x. I'm going to speed up this process a little more now that we're used to it. I see that I'm multiplying by 2. I feel like getting rid of the 2 or undoing the 2 is going to be the best choice for this step, though it may not be the only choice. It's not the only correct choice. The inverse of multiplying is dividing, so I'm going to divide the entirety of the side by 2. And what I must do to one side, I must do to the entirety of the other. I've shown my work. What's left? 4 divided by 2 is 2. And this multiplication by 2 will be canceled by that division by 2, leaving the square root of 9 minus x. I'm still going through the process of getting x by itself, alone and positive on one side. I'm going to choose to undo the square root. The inverse of square rooting is squaring, so I'm going to choose to square both sides. I've shown my work. 2 squared is 4. The square root of anything squared cancels out, leaving what's under the square root sign. Now I'm very close, but I've got to be careful. What am I doing to x? This is a little odd because we have the 9 that's coming first. So we're taking x away from 9. But I want the 9 to disappear from that side. This 9 is positive. I don't have to show the plus sign in front of it. It's implied that if a number doesn't have a sign in front, it's positive. So how do I cancel out this 9? I'm seeing a positive 9. The inverse is subtraction. I'm going to do that to the entirety of both sides. And when I do, this positive 9 and negative 9 cancel out. What's left, now we've got to be careful, is the x, but also the sign before it. This is a negative x that is left on that side once the 9s have been canceled out. And on the left side, 4 minus 9 is a negative 5. Now, x is alone, but it's not positive. So to finish solving for it, I've got to undo this negative. How do I do that? Technically, I am multiplying by negative 1. That's how we can show the work. You can speed it up by thinking, well, I'm going to change the sign of the entirety of both sides. But mathematically, the operation that you're doing is multiplying by negative 1. So negative 1 times a negative x will be a positive x. And a negative 5 times a negative 1 changes its sign to positive. We have solved for x, and the value that x is equal to is a solution to the original equation. I could put the variable on the left. Don't have to, but that is typically how we present a final answer. Now, what does it mean for this to be a solution? A solution is a value or values that make a relation true. That means that if I substitute this value 5 into the original equation, I should make that equation true. Well, what does it mean to make it true? Let's see. Let's do that substitution. I'm going to rewrite the original equation. 0 is equal to 2 times the square root of all 9 minus, but now instead of x, I'm going to substitute the value 5 in, because I believe that 5 is the solution, and I finish up minus 4. There's no variables in here. I'm going to evaluate both sides. 0 is going to wait. It's already as simple as it can get. 9 minus 5 is 4. So this is 2 times the square root of 4 minus 4. Continuing, the square root of 4 is 2. So 2 times that is 4. And if this is all 4, when I subtract 4, I get 0. And I can observe that after evaluating both sides, the last step is something that is absolutely true. 0 is equal to 0. It's a proof or a justification that the original sides must have been equal to each other. So here I can circle, I have checked that 5 is indeed the solution.